One final example of being able to find the curvature, we have a vector value function 3 cos ti, 3 sine tj, 4 tk at the point 3, 0, 0. So what we want to do first is we want to solve for t. So if we solve for t, we get 3, and remember the trick is we just set the first component of I, the coefficient of I, equal to the first coordinate. And so 3 cos t is equal to 3, or in other words, cos t is equal to 1. And we know that that occurs in a number of places, 0, 2 pi, 4 pi, negative 2 pi, etc. But we also need 4t to be equal to 0 as well. So it seems like t equals 0 is probably going to be the best location for this. All right, so now we know t. Now we have to find r prime and r double prime and then cross those. R prime is going to be equal to minus 3 sine t plus 3 cos t I, j, and then plus 4k. And then r double prime is going to be minus 3 cos t I minus 3 sine t j and 0k. And I'll put that in there. Now what we're going to do is we're going to set up a determinant for this. All right? So when we set up the determinant, we're just going to utilize the cross product. This should be a cos of ti or j. Right? And we're just going to use our cross product. So we're going to set up r prime cross r double prime. And that's going to be I, j, k. We have our minus 3 sine. We have our 3 cos. And then we have our 4. And then we have 0. We have negative 3 cos t. And then we have negative 3 sine t. All right, so we're going to find the determinant. And we're going to find the cross product. So we're going to cross. And when we find the cross product, we get 3 cos t times 0 minus a negative 12 sine of t. So it's going to just be 12 sine of t I. For the j, we get negative 3 times 0. And then we also get negative 3 times 4. So that's going to be a negative 12. So it's minus a negative 12. So that's going to be a positive 12. But we keep the negative out front. So that's going to be 12 cos of t j. And then for k, we're going to end up with 3 times 3 is 9 sine squared. And then minus negative 3 times positive 3 is another 9. So we're going to get a positive 9 cos squared of t k. Or we could just write this as 12 sine ti minus 12 cos t j, and then we have a 9 sine square and a 9 cos square, so that's just going to be 9k. All right, so let's hold on to that, right? And once we're done, we can find the magnitude of that. All right. In fact, we should probably find the magnitude anyway at this point. All right, so if we find the magnitude, that's going to be the square root of 12 sine t squared plus negative 12 cos t square plus 9 square. Right? And when we go to compute this, that's going to be 144 sine square t, 144 cos square t, plus 81. All right. And we know that this is just going to turn into 144 plus 81 because of the sine square cos square relationship. All right, it looks like it's going to be a 225, 195, excuse me, a 144, sorry. It is a 225, and the square root of 225 is going to be 15. All right, so that's nice. That works out really clean. All right. Now the other thing that we need is, and by the way, that's R cross R double prime. All right. So it's really nice. And now we need R prime at t, and we need to take the magnitude of that and then cube that. Okay, so let's just first of all find the magnitude of R prime. And we're going to go up here. So we have -3 sine, +3 cosine 4. That's going to be the square root of -3, forgot it already, sine t squared plus 3 cos t square plus 4 square. All right, and writings on the wall for this. Again, we're going to get a sine t and a cos t squared, so 3 sine square t, 9, excuse me. So 9 sine square t plus 9 cos square t plus 16. This should just wind up being 9 plus 16 under the radical, so 9 plus 16 is going to be root 25, or just 5. All right. And so finally, we can find the curvature K. And the curvature K is going to be, remember our formula, R prime cross R double prime magnitude divided by R prime magnitude cubed. Right? So that's going to be equal to, remember we got 15 in the numerator, and then over here, so that was 15 from right here, and we're going to get 5 for our magnitude cubed. So we really get 15 over 225, or 115, or 125, excuse me. So we're going to say 15 over 125, and that ends up being 3/25. All right. Now, we're really looking for K at 0 when t is equal to 0. But that's really easy because K at 0 is 3/25. In fact, K at n, where n is any point, or K at t, is 3/25. So what does that mean? Well, what that means is that the curvature is going to be the same no matter where you are on the function. Okay, so this means the curvature is 3/25 at all t on our function r of t. All right, and how does that make any sense? Well, if we go back up to the top, you might remember that this function, 3 cos, 3 sine, 4t, is actually a helix. Okay, and it's actually going to spiral around the z-axis. And the helix is going to increase at the same rate. So if we have our helix, it's just doing one of these things around the axis. And the curvature is the same no matter where you are on that helix. In fact, that's one of the properties of any helix, to where the first two, or the sine and the cosine, have the same coefficient. So that's actually a pretty cool type of problem, to where we can find the curvature of a helix and demonstrate that no matter where we are on the helix, it has the same curvature.